A snail sits at the bottom of a pole. The pole is 10 feet tall. Every day, the snail climbs 3 feet. Every night, while it sleeps, it slides back 1 foot. When does it reach the top? Pick a number now, before I say anything else, because whichever number arrives first is the one this question was built to catch. And here's the part that stings. It is not a hard sum. The people who miss this divide correctly and subtract correctly, and the number they hand over is still not when the snail gets there. The mistake happened one step earlier, before any arithmetic at all. In the picture, they were doing the arithmetic on. Here is the answer almost everyone gives. 3 feet up, 1 foot back, so 2 feet a day. 10 feet of pole at 2 feet a day is 5 days, the end of day 5. Every step of that is right. 3 minus 1 really is 2. 10 divided by 2 really is 5, and nobody fumbled a multiplication. Some people go one step further, and they feel rather good about it. They notice that on the last day, the snail has no reason to slide back. So they look at how high it gets during a day. Day 1, 3 feet. Day 2, 5. Day 3, 7. That is twice the day number plus 1. Set that equal to 10, solve for the day, and out comes 4.5. That one is wrong too, and it misses in the other direction. So there are 2 careful calculations here, and neither of them is the answer. The fault is not in the sum, it is in the picture the sum was built on. So let us go and look at the picture. Those 2 wrong answers are exactly why this question gets asked in a first interview round. Plenty of people watching will get it right and still walk out of a real room without an offer. Somebody on the other side of the table is writing while you talk, and almost nobody ever sees that sheet. 15 years of hiring in finance is where I learned what goes on it. So I wrote the Quant interview playbook around what is actually being scored, with 4 mock interviews and the marking written down the margin. Link is in the description. Now, the snail. Forget the division and just walk it, one day at a time. Along the bottom is time, and up the side is how high the snail is on the pole. The climb is spread across the whole day, and the slide happens overnight, between one day and the next. Day 1. It climbs 3 feet, so it ends the day at 3. Then it sleeps, and it slides down to 2. Day 2 starts at 2, climbs to 5, comes back down to 4. Day 3 starts at 4, reaches 7, falls to 6. Day 4 starts at 6, gets as high as 9, and settles at 8. Now look at the mornings. 0, 2, 4, 6, 8. 2 feet for every full day and night, exactly as advertised. That part of the story was never wrong. But look at the tops of the strokes as well. 3, 5, 7, 9. Not one of them touches the 10-foot line. So 4 days go by, the snail has never once been at the top, and the 2 feet a day picture describes all 4 of them perfectly. Now day 5. The snail wakes up at 8 feet. It climbs 3. 8 plus 3 is 11, and there are only 10 feet of pole. So somewhere inside that 5th climb, it goes over the line. And the moment it does, the story ends. It is at the top. No night follows, because every night in this problem came after a day that finished below the top. And this day does not finish below the top. How far into the climb? It needed 2 feet, and the climb is 3 feet long. 2 out of 3. 2/3 of the way through the climb on day 5. That is the answer. 4 whole days, and then 2/3 of the way up the 5th climb. Put that next to 5 whole days, and the gap is 1/3 of a day. The reflex was late, and it was late for one reason. It charged the 5th day, a night the snail never had. There is a second road to the same day, and it is the one worth carrying into a room, because it still works when somebody changes the numbers on you. Take the last climb off the pole before you start. From 7 feet, the snail is home, because 7 plus 3 is 10. So the question was never when it reaches 10. The question is when it wakes up at 7 feet or higher. And below 7, nothing strange happens at all. Every full day and night is worth 2 feet, honestly, all the way up. 7 feet at 2 feet a day is 3.5 days. Half a night is not a thing you can have, so round it up to 4. And notice what that fraction just did. It did not become the answer. It told us to round. 4 nights, and the snail opens its eyes on the morning of day 5, standing at 8, with a 3-foot climb that finishes the job. Same answer, and now it is a rule instead of a lucky guess. Count whole cycles only while the next climb still cannot finish. Then finish the last climb by hand. And now the part I like most about this question. Go back to the reflex for a second. 10 over 2 is 5, and the true answer is day 5. It got the day right. That is luck, and you can take the luck away by moving one number. Make the pole 9 feet instead of 10. Same snail, same 3 up and 1 back. The mornings do not change, 0, 2, 4, 6. And on day 4, the snail climbs from 6 to 9. 9 is the top. It touches the top on the last inch of day 4, and the moment it touches, it has stopped. Now ask the reflex again. 9 over 2 is 4.5. Same number as before, reached by a different mistake. And this time, it is late instead of early, because the snail has been at the top since the end of day 4. With a 10-foot pole, the division named the right day and the wrong moment. With a 9-foot pole, it names the wrong day as well. Even numbers of feet are where it gets away with it. Odd ones are where it does not. And none of that has anything to do with the actual mistake. So what was this question really for? Not the division. Whether you notice that the last step of a repeating process does not behave like the ones before it. The snail slid back 4 times, not 5. The 5th slide would have had to happen after the snail had already arrived, and a thing that has arrived does not slide. Every night in this problem is a night that follows a day that failed. You have met this shape before. 5 fence posts make 4 gaps. A week of work has 1 fewer handover than it has days. And nobody in a real room is marking the last line you write. They are marking whether you looked at the edge of the pattern before you trusted the middle of it. I have coached hundreds of people through these rounds, and some of them landed the seat they were aiming at, north of $500,000 a year. Knowing how to solve one problem is worth something today. Knowing what to do every morning between now and your first interview is what gets the seat. So the Quant interview playbook has an 8-week plan and a 12-week plan, written day by day, and 411 pages of material for those days to point at. 281 problems, every one worked through. Link is in the description. Open the plan that matches the weeks you actually have and start tomorrow morning. 10 feet of pole, 3 up, 1 back, 2/3 of the way through day 5.